inverse of a 2 by 2 matrix. So we'll start by a 2 by 2 matrix, and then we go to a 3 by 3 matrix. And we said, when I say a 2 by 2 matrix is a matrix of order 2 by 2. It has 2 rows and 2 columns. That is just a revision. So we have the procedure. So the first thing you'll have to do when you are doing an inverse of a matrix, or you will find the determinant. So this is the first step you'll do. You'll find the determinant. Then after you found the determinant, you will interchange elements in the leading diagonal. You know where the leading diagonal is. So interchange elements then number 3, you'll multiply elements in the other diagonal by -1. So lastly, you will multiply the resultant matrix by the reciprocal of the determinant. The reciprocal of the determinant. Determinant to define. So let us start with the first step. So for example, we have a matrix. We have a matrix 5. So this is matrix A, which is 5, 3, 4, 2. So those are elements on a matrix A. So find A inverse, or find the inverse of A. It's denoted as A raised to -1. Or I can just say find the inverse of matrix A. So you can find either it can either be written as this or just in long form yake ni just find the inverse of matrix A. So the first step, find the determinant. We know how to find the determinant. Okay, it is 5, 3, 4, 2. The determinant. I say determinant can be written as det. Det or that. So find the determinant of that. So we said that we identify the leading diagonals. The leading diagonal. You first identify the leading diagonal, which is, we said you start from the first column, the element of the first column, first row, going diagonal wise. Not perpendicular. Perpendicular is at yani chini yake 90, but perpendicular, yeah, but diagonal yake twende hivyo. So 5 and 2, that is the leading diagonal. So that is the leading diagonal. Then the other diagonal is just the other diagonal. So we say we multiply elements on the leading diagonal, 5 times 2, minus element on the other diagonal, which is 4 times 3. So it is 10 minus 12, which is equals to -2. So the determinant is -2. So we go to the next step. Tuiache tu hiyo, tutaitumia. So we go to the next step as interchange elements in the leading diagonals. Tumeona penye leading diagonal iko. So just interchanging the element. Tulisema each number here is called an element. So interchange elements in the leading diagonal, meaning the 2 will come here, the 5 will come here. Just interchange. Okay? So our resultant matrix 2 itakuja hapo juu, 3 ikuje hapo, na hiyo 5 ikuja hapo. So we have done the second step. So this is the step 1. Step 1, we found the determinant. Step 2, interchange elements in the leading diagonal. Interchange elements in the leading diagonal. That is step 2. Step 3. Step 3 is to do what? Multiply elements in the other diagonal by -1. So elements of the other diagonal we multiply by -1. So the step 3, 2, then 3 times -1, then 4 times -1, then 5. Sindio? So our resultant matrix will be 2, -3, -4, 5. Sindio? So the last step, which is step 4, step 4, niangalie kama wataona hapo kiandika. So step 4, it is, we do what? Multiplying the resultant matrix by the reciprocal of the determinant. The reciprocal of -2 is, the reciprocal of -2 is -1/2, sindio? So it will be 2 -3 -4, 5. Okay. So we multiply by -1/2, sindio? So it will be 2 times -1/2, -3 times -1/2, -4 times -1/2, and 5 times -1/2. So it will be 2 times -1/2 will be 2 times -1/2. So it is -1, -1, -3. So here tutakumbuka ile kitu yetu ya
hapo itakuwa 3
tutakumbuka ile kitu ya positive, negative plus negative times a negative is equals to a positive. A positive times a negative is equals, so negative plus a negative times a negative plus a positive times a positive is a positive. Negative times a positive is equals to a negative, and a positive times a negative is negative. So put in mind that one. So when we say -3 times -1/2, itakuwa 3/2. Sindio? 3/2. Then -4 times -4 times -1/2 power 1 hapa 2, sindio? So itakuwa positive 2, sindio? Then 5 times -1/2 will be -5/2. So this is the A inverse. This is the inverse of
Hata hapo kama ni fraction on. Okay, it's okay, but ile negative 1 ingeza kuwa tu
1/2.
2.
Wapi hapa?
Okay, it's okay.
So it is, yeah. So that is A inverse. A inverse. If this is A inverse is that. Okay? Yeah. So we have known how to do inverse of 2 by 2 matrix. So we follow the steps. Step 1, we find the determinant. We have found the determinant, the leading diagonal, multiply elements, the leading diagonal minus element on the other diagonal. We find our determinant as -2. Then step 2, interchange elements in the leading diagonal. So the leading diagonal is this, sindio? The leading diagonal is that. So we interchange elements. So the 2 inakuja hapa juu, 5 inakuja chini. Then the third step is multiply elements in the other diagonal by -1. So we have identified the leading diagonal, the other diagonal is this. So it will be 2, then 3 times -1 and 4 times -5. Inatupea hiyo. Then we go to the last step, which is step 4. We multiply the resultant matrix by the reciprocal of the determinant. We found our determinant as -2. So its reciprocal, it will be -1/2. So the resultant matrix, we multiply by -1/2. And we learned about multiplying a matrix by scalar quantity. So we say that if a matrix, if you want to multiply a matrix by a scalar quantity, you will multiply each element in the matrix by the scalar quantity, sindio? So we multiply each element by -1/2. So tutapata our matrix, which is A raised to -1 as that. So we have found that there is something small that I want us to do. We have A and we have A inverse. We want to see if we multiply A, matrix A, by matrix A inverse, what do we get? So that is something I want us to do. Okay, before we do that, okay, let us do this. Let us put a note first. Before we continue, let us put a note. An NB. 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 If a matrix has, if we find that for a particular matrix, we find that its determinant is 0, that element has no inverse. Tuseme, we find that a matrix, when you are finding the determinant, unapata ni 0. Tunasema hiyo element haina inverse. Let me just, if the determinant is if the determinant of a matrix is 0, umefind the leading diagonal, the elements of the leading diagonal minus elements of the other diagonal, umepata 0, then the matrix has no inverse. The matrix has no inverse. haina inverse, cause for example here is 0. When you multiply by the reciprocal of the determinant, the fourth step, which is multiply the resultant matrix times the reciprocal of the determinant, unapata ati hapa hivi you multiply by, if the determinant is 0 uta multiply hapa by 1/0, of which ukimultiply hapa na 0 si itakuwa tu 0, so meaning it has no inverse. It has no inverse. We refer to them as singular matrix. We refer as singular matrix. We refer to them as singular matrix kwa sababu haina inverse. When you do its inverse, tuseme for example, let's say just A, B, C, D times the inverse of the determinant. Determinant is 0. Si kila kitu hapa itakuja ikue 0 0 0 0. Yeah? That is a singular matrix. Its determinant is its determinant is 0. Its determinant is 0. If the determinant of a matrix is 0, if the determinant of a matrix is 0, the matrix has no inverse. We refer to them as singular matrix. Okay. So tutakuja hapo tufanye example moja kali. I'll come to that. There is something I want us to do with multiplying A times A inverse. This was just an NB, andika kando NB, that if the determinant of a matrix is 0, the matrix has no inverse. We refer to them as singular matrix. So if somebody asks you what a singular matrix is, you uko na jibu, si ndio? Its determinant is 0. A singular matrix, its determinant is 0. Si sawa hiyo, because tutakuja nayo tutumie mahali. Okay? Yeah. So tumesoma about getting the inverse na tumesoma about singular matrix. Determinant is 0. Okay? So tunafuta hapa. What has to multiply? Nataka to multiply. We want to multiply, find A times A inverse. Multiply matrix A times its inverse. Okay? So utakuwa matrix A is 5, 3, 4, 2 times -1, 2, 3 over 2, then -5 over 2. So when you are multiplying, tulisema you multiply a row, each column. Row, each column, row, each column. So we start as so A inverse is equals to natumia space kubwa, handwriting yangu ni kubwa sana. So anyway, yeah. So it's 5 times -1 plus 3 times 2, then 5 times then 3 times 2, then again 5 times 3 over 2 plus 3 times -5 over 2. Then we go to the second row with each column. So 4 times -1 plus 2 times 2. Then 4 times 3 over 2 plus 2 times -5/2. So if you notice, let us see if you're correct. Hiyo, yani inafanana. So we continue. That is just something that you can just notice, yani ukipitia una notice tu hapo kuna resemblance fulani, na unapiga tick, alafu unafanya nini? Unaendelea, unalala. We student wangu amelala. Surely. Na mimi napiga domo hapa. I hope wewe mwenye uko una watch haulali kwa sasa. Ni story gani? Anyway, tuendelee na wenye tunaendelea na wao. That's why you need a calculator. Tukikuwa tunafanya hesabu unafanya calculator. Unafanya calculation anyway. Ni sawa. So 5 times 5 times -1 is -5 plus 3 times 2 3 times 2 ni ngapi? 6, ndio? 5 times 3 over 2. 5 times 3 over 2 inakuwa 15 divide over 2 plus 3 times -5 over 2. -15 over 2. 4 times -1. 4 times -1 is -4, si ndio? 4 times -1 ya -4 plus 2 times 2, 4. Then nimekaribia, -4 plus 4. Then 4 times 3 is 12. 4 times 3 ni ngapi? 12, yeah. 12 over 2 plus 2 times 5 -2 2 times -5 times 2 times -5 ni ngapi? 10. -10 over 2, si ndio? So itakuja ikue a -1 is equals to -5 plus 6 itakuwa 1, si ndio? 15 over 2 plus -50 over 2 itakuwa 0, si ndio? Tulikuwa tumeandika hapa, by the way, positive times a negative is equals to a negative, si ndio? -4 plus 4, 0. Tunakumbuka hiyo? Hapa ni 0, huku ni negative, si ndio? -1, -2, -3, -4. So kwa -4 plus 4, 1, 2, 3, 4 inakuja kwa 0. Hizi very important. So I hope unazikumbuka pia. So 12 plus -10. So it's 2 over 2. 2 sitakuwa 2 over 2, which is 1. Okay. So you get 1. So this type of matrix, inaitwaje? So if you multiply a matrix times its inverse, inafaa ikupe a unit matrix. Unit matrix. So this is a unit so NB A times A inverse is equals to a unit matrix. Okay? Sikutaka kuandika in long form that when you multiply a matrix times its inverse, itakupea unit matrix. It's just the same as this. A and B. A matrix times its inverse, it gives you a unit matrix. But sijui niandike kwa wale A and B. Acha nione kama inafika hapo. Iko sawa. A and B. If you multiply a matrix by its inverse, you get a unit matrix. You get a unit matrix denoted as I. Denoted as I. A unit matrix ni the diagonals, the leading diagonal is 1. So the elements in the leading diagonal is 1 and the other element is 0. Yeah? So when you multiply a matrix times its inverse, it will give you a unit matrix I. Okay? Yes. So that's just about inverse of a 2 by 2 matrix. Then after we have done that, we want to see how we will solve simultaneous equation using matrix. Okay? Solving simultaneous equation using matrix. Yes? Mpaka hapo tuko pamoja. Okay.